Good morning, everybody, and welcome back to Next Door NetAdmin. Today, I'm going to talk a little bit about how Cisco passwords are stored in their configuration file, or maybe rather, how passwords are stored in a Cisco configuration file. That makes a little more sense. There's a few different types of passwords that you can see notated down in a configuration file. There's passwords for everything. There's passwords for logging into the console. There's passwords for logging in through SSH or other local services. There's passwords for routing protocols, whether that's EIGRP or OSPF or what have you. There's passwords for VTP, your virtual trunking protocol, or VLAN trunking protocol, whichever it is. There's lots. And while they have the capability to interface with a standard radius system for authentication or a TACACS system, which is Cisco's proprietary version of a centralized authorization and accounting system, you can also have passwords configured locally in the configuration file. And for some things, like the console port, that's pretty much all you've got, because the console port is the thing that's supposed to remain functional even if you don't have it hooked up to anything else. So it's kind of important that it's using a local password. Now, how do we safely store those passwords in a configuration file so that if somebody gets a hold of our configuration dump, all of our passwords aren't immediately known to the world? A couple different ways to do that. First of all, let's look at what happens when you actually type in a password. If you type in a password and you type in what the password should be, if you don't specify otherwise, the router will take that password and store it in the configuration file, just as it is. Which is, generally speaking, not what you want. If, however, you enable service password-encryption, then when you type passwords into a device, whether it's a router or a switch, I should add, because this is true for both types of devices. This is not router specific. Once you enable service password encryption, then when you type a password in, it will change the password to whatever the default is for that particular type of password, that command. For console password, from what I have seen, this will generally default to a type 7 password. If you type something like enable password and give it a password, then that'll also be type 7. If you do something like enable secret, that's a different level of encryption. And so by default, it would choose something like type 5 if you're on an old device, or type 8 or 9 these days, but we'll come to those in a minute. Once it's in the file, in the configuration file, you'll see it there as the command, but it'll have a number attached. It'll have something like password 7 and then a random looking string of letters and numbers. Or it'll say enable secret 5, $5, $, and then a whole bunch of other stuff. These numbers denote the type of password. And so you'll hear this referred to as a type 7 password or a type 5 password or whatever it is. So what are these actually? Are these actually secure? Do they do the job? Some of them do. Some of them not so much. Let's start with a type 0 password. Type 0, you don't want to see, because type 0 is plain text. It just is what it is. You see the password in all of its unencrypted glory. Wonderful. That is, technically speaking, a type 0 password. And if you load in a configuration file with something like password 0 and then the value, that's just the value. You're telling it, this is unencrypted, don't treat it like it's encrypted. Okay, fine. Next up, type 7. Very common. exceedingly common, exceedingly weak. It's based on something called a Vignere cipher, which once it's been broken, and this definitely has, it uses a hard-coded key that is the same across all Cisco devices everywhere. Once that key is cracked, deciphering a type 7 password is easy peasy child's play. You can Google type 7 password decryptor and you'll get 10 results, all of which will give you the result. You just type in the encrypted value and it spits it out. Oh, it's actually this. Okay. So it's not a barrier to a determined attacker. It's obfuscation, and that's it. That's just to stop casual snoopers who are looking at it and going, nothing unencrypted. It's not worth my time. I'll go somewhere else. That's all that it does. So is it secure? No. It's just obfuscation, but it is one of the more common ones that you will see. Particularly because for some things like the console port, Type 7 encryption, as far as I know, and I could be wrong about this, but as far as I know, Type 7 encryption is basically the only thing that is there. That's what you get. But once you're in the console, in order to actually get to the privileged execution mode, you'll hopefully have another password like an enable password, or in this case, an enable secret. Enable secret uses a one-way hash that you can't decrypt to actually get the previous value. And this is where we would find a type 5 password, classically. Type 5 passwords are a salted MD5 hash. So in the value that you see in the configuration file, there's an indicator that it is a type 5 password. There is the salt, and then there is the actual hashed value. When you're authenticating yourself, you type in a password, it salts and hashes it to compare it to the stored value. If it matches the stored value, you're good, in you go. Cool. It's a little more secure because it's not meant to be reversed. It's a one-way transform only. But MD5 is known weak at this point. Nobody uses MD5 anymore except for very, very casual verification because it's no longer considered cryptographically secure. And this is where we come to the next part of our story, which is what happens when you get a security upgrade wrong. Cisco knew that type 5 passwords were becoming insecure. This was back in 2013. Probably 2012 is when they started this process. And they went, okay, well, if type 5 passwords are insecure, let's come up with a new type of password. And we're going to implement a different algorithm with SHA 256, pretty sure it's 256, and we're going to do multiple iterations of it as current best practice dictates. Yeah, okay, it's going to be salted and everything else. Okay, fine. And they called it type 4. So they roll it out, and when you type in at the console, enable secret, and then give it a password, it just applies the default that's built into the OS, the iOS in this case, or it did. These days, I think there's a way that you can actually tell it which algorithm you want to use, and it'll change the type accordingly. But at the time, it was just enable secret, put in a password, and it'll use the default. If you wanted to choose a different one, you had to include the number to indicate the password type and then give it the encrypted value. This was so that you can load an old configuration file without having to change a bunch of formatting. Cool. But if you're typing it in fresh at the console, you want to use the type that is most current, the most up-to-date, the most secure value. Cool. And if you gave it an old type 5 password, it would also give you a warning. Warning, this is going to be deprecated very soon. It works for now. You should rerun your command with the original value to convert it to a type 4 password that'll be saved in your configuration going forward. And so it warned people about this. Okay, we've got a new algorithm. If you type in a password, it's going to just use the new algorithm. And if you type in an old password or load an old configuration, it's going to warn you this is going to go away at some point. You should upgrade it to the new algorithm. Okay. They got it wrong. A couple of people looked into it, researched it, and found out that how Cisco had designed it would have been correct. But when it was coded into the router software, they didn't correctly implement the design. What happened was it would take your password, and instead of doing multiple iterations of SHA-256 the way it's supposed to, it did one pass. And that was it. This actually made the type 4 passwords less secure than the type 5 passwords that they were trying to replace. And at the time, there was no way to get the device to switch to go back to using the type 5 password, other than by giving it a password that had already been encrypted. Cisco said if you have another device that is still generating type 5 passwords, feel free to put your password in over there and then take that line of code and copy it over into your newer device. Or if you had access to OpenSSL, Cisco also published a command that you could use to essentially encrypt your password into the Cisco specific format at the command line of like a Linux box or something. And then you could take that value and paste that in. But there was no way to actually tell the router itself, I want you to stop using type 4 and I want you to use type 5. And when that happens, you can't fix it. There's no way to fix that. Think about what would happen if you took a type 4 password and then you upgraded the operating system to say, okay, we got it wrong the first time, so now we're going to change it so that a type 4 password is done with the correct number of iterations and everything else. Well, when you do an upgrade, your router is going to take that password that is saved in the configuration file as a type 4 password, but now when it boots the next time and you type in that password, instead of doing a single pass, it'll do the multiple passes that it's supposed to, and then compare it to the value in the configuration file, and it won't match. Even if you've got the right password, it won't match because you changed what the algorithm was doing while keeping the same type of password. So updating your software alone is not going to do the trick. Now, you might try and take this a step further and say, well, what it should do is try the new version of the algorithm first. And if it doesn't work, then we know that maybe this is an older type 4 password that used the old broken algorithm. So then we should check it against that. And if that matches, then it's valid and they should let somebody in. Not really. You could do that. It would work. It would also be a massive security weakness forever. Because all you need to do is get a copy of a password, any password, that was done under the old broken system that was easier to break, and slide that into your configuration file through whatever method you want, whether you compromise a TFTP server that was doing auto configuration, or you slid an altered copy of a paper printout of a configuration into, somebody's desk so that when next time they go through the comparison, they go, oh, this is wrong. I'd better update this to what was on the paper. however you want to do it, if you can replace that configuration with the weaker version of the password that's already been compromised, then the router is just going to say, is this using the new secure version? No. Okay, well, let me just automatically try the less secure version. Oh, hey, that worked. I guess that's valid. That's the kind of security weakness that never, ever, ever goes away. So for all intents and purposes, once Cisco released a broken type 4 password scheme, that was permanent. There's no way to undo that. Type 4 passwords are broken, insecure. They're worse than the type 5s that they were supposed to replace. Nobody uses them. Nobody should use them. So what do we have to replace them? Well, Cisco did go back and implemented their designed replacement correctly the second time around. These are now called type 8 passwords. Type 8 passwords use all the iterations that they require. They're still basing this on SHA 256, and it is very secure. There's also a type 9 password. Type 9 does much the same thing. It's a one-way hash. It can't be reversed, but it uses a different algorithm called encrypt. Both of them are secure. They offer two different ones in case you have a preference for which one you want to use. It's up to you. They're both secure. There's also a type 6 password, which is reversible, much like a type 7 was. And this is necessary for specialized things like VPNs. If you need to actually have a key that needs to be available in plain text, but you don't want to save it as plain text, then you can use a type 6 password, which is encrypted using AES 128. Very standard, very secure encryption. But it requires that the router be configured with the encryption password that you're going to use to encrypt and decrypt this configured password in your configuration file. And your encryption password is not saved in the configuration file, so it doesn't become a part of the actual static configuration, which also means that when your router reboots, somebody's going to need to log in and give it the encryption password again, or you're going to have some sort of automatic recovery that's going to feed it the correct value so that it can decrypt the password in its configuration file. It's a bit of a hassle. It's very rarely used because for most things, a hash is good enough. You really only need it for VPN keys and similar. If you look at the specs that the NSA in the United States has put out, they strongly recommend that you only use type 6 encryption for VPN keys. And that is where it's approved. For everything else, it should be type 8 or type 9. Type 8 is preferred because it's a very NIST standard implementation, SHA 256. Cool. And they say you should not use type 0, obviously, it's plain text. You should not use type 7, it's obfuscation. It's not secure in any stretch of the imagination. You should not use type 4 because that's also been broken. And you should only use type 5 if your device does not support type 8 or 9, which is the upgraded ones. If it doesn't support the upgraded ones, fine, type 5 is still the best you can get without going to those new ones. So you'll still see type 5 in a lot of places because either it's an old configuration file that's been moved forward, or it's an old configuration that was moved to a device that was capable of type 4, and the administrator went, oh, but I'm not supposed to use type 4 because that's actually less secure than type 5. So I need to find an old password and bring it forward. Or it's just a habit at this point. MD5 is not secure anymore, but it's still what we use in a lot of places. So yeah, that means in a configuration file, it's kind of important to note what type of password it is. Type 0? No, not so cool. Type 7, you can give me any type 7 password. I will probably decrypt it just for fun. At this point, if I see a configuration file with a type 7, I'm just going to go, oh, I wonder what that is. Bloop. Oh, cool. That's what that is. Type 5, I know it at least has a basic level of security. Type 4, you were unlucky. You're using the thing that Cisco did incorrectly, and you never caught the message saying, hey, this is actually less secure than type 5. So if you're using type 4, you were first unlucky and then you weren't paying attention. If I see type 6, that is a very specialist configuration. Type 8 or 9, okay, you're using something that's up to date. That's a good start. And your configuration is relatively new. Either that or you've upgraded your configuration after you brought your configuration file over to new hardware, then you upgraded your password. Either one of which is good. So yeah, 0, 4, 5, 6, 7, 8, 9. There is no encryption type for type 1, type 2, or type 3, but I guess those numbers are still out there for Cisco to use in future if they want. Either that or they'll go to 2-digit numbers, kind of like the Diffie-Hellman groups, where Diffie-Hellman group 1 was very common, and then the next most common was like 14, 15. And it kept on going from there as the groups increased. So yeah, that's basically it. A short little monologue on Cisco password types, what they're used for, what you'll see, and an intervening story on what happens when an attempted security upgrade goes wrong. So yeah, hopefully that was a fun little way to start off your new year, and hopefully you found it interesting. If you have any thoughts on things you'd like me to talk about or cover, let us know down in the comments. For now then, thank you very much for watching. I am your next door NetAdmin, and we will see you next time.